we can go ahead and have the classes regularly through this Cisco WebEx meeting. Also, for those who are not able to join us in this class, so I see around 18 participants, this on our departmental page so that they can download from there. CR, you started recording, right? Okay. Is my voice clear? Okay. Since my notes are back in the office, plus I don't have my PPTs around, so I would be using the PowerPoint presentations which come with the textbook that we will be using. That is the computer networking or top-down approach by Koros and Ross. In case you do not see the shared slides, what you can do is I'll give you a link. You can download these slides on your own. Okay. And in between, if you have any question, you can stop me. I mean, just ask a question like normal you can, or you can also write the question in the chat on the right side. Is that okay with everybody? Okay. All right. In the meantime, you can put your, microphones switched off. Whenever you have to ask, only that time you can simply start the microphone. Now, firstly, to start with computer networks, why are we discussing these computer networks and what is the goal of our this course of computer networks? Firstly, we would try to understand what would be the benefits of computer networking, how this network development has helped overall, what are the models and best practices of computer network, how do you plan a computer network, right? We'll start with the introduction first, advantages, types, then we'll move on after the introduction to the ISO model of the networking, that is the 7-layer model that we know, ISO OSI reference model. And that would be our basically main goal, to cover all the 7 layers of computer networking OSI reference model. To start with, we have seen that if we have a single PC, we would call that PC as a standalone PC. What is a standalone PC? A PC that is not connected to any other PC. But then since we have nowadays information flows such that we would necessarily require data to move from one device to another device, so we would need that computers should be connected. From there, we move on to a PC connected to another PC. That is where the basis of computer networks starts. You can transfer data through other models as well. Like, for example, you use a flash drive to transfer data from one PC to another, the pen drive that you call. But then the time, the effort, transmission of same data from one end of the world to the other end of the world won't be same. It might take days to transfer data through a pen drive. As compared to that, if you take a simple, the messaging that you do, let's say through Yahoo Messenger or Facebook Messenger, it takes a fraction of second for a message to transmit from one end to another end. Another thing that we will understand from this course is the basis of networking, or the basic of networking, like networking from computers to printers or other equipment. And why do we necessarily need to understand that? We have to understand nowadays that whatever device that you see that are coming on in this planet are nowadays web enabled. What we say web enabled, if they have the possibility of connection to the internet. For example, if you buy a refrigerator, it would be with a logo IoT enabled or Wi-Fi enabled. You buy an AC, it would be IoT enabled. The cars nowadays come with these logos of IoT enabled cars. And what are these? Basically means that your device that you have purchased has the capability of connecting to the internet. By 2020, it was forecasted that around 33 billion devices would be connected to internet. So what are these devices? Like I gave you examples now, apart from your mobile phones and computers. That's why it has become so necessary for us to understand these protocols, the host, access networks, the physical media that help us to connect to those devices, what we presently know as Internet of Things. So we'll have in this first unit or first chapter, what would be the internet, the history of it, and then we'll move on to basically is a we'll try to understand what are the different user nodes or general nodes that come, how is a packet or information sent from one device to another device. Then we'll move on to the performance of the network. And after that, we'll see the basis of how we'll start with the protocol layers. This would be the start of our chapters. Now I'll move to the next slide. Is the next slide visible? CR? It's still there. Okay, what I can do is, in the meantime, I can send you the link of where you can download this PPT. In case you cannot follow me on this slide sharing, can you go and download this slide? Go to this link that I have shown in the chat. Go to chapter 1 introduction and go to version 8.0, that is for 2020. All right. So just download from there. So you can follow me then through the downloaded PPTs. Then you won't have an issue of maybe because of net connectivity, you cannot follow the slides. So I'll be moving on to the third slide. It says the internet, a nuts and bolts view. So guys, have you downloaded? All right. Okay. So I just now mentioned that we have billions of devices that have been connected to the internet. In these billions of devices, you as a user, we will be calling them as hosts. We can call them as end systems as well. And we will be running our applications on these network edges. So keep a note of this, that we are discussing network edges as your laptop, your mobile phone. If you see the picture in the PPT, the network edges are displayed by the laptops at the bottom. These would be running the applications, and these applications would help us to connect to a server. For example, at this moment, we are using Cisco WebEx. Okay. Cisco WebEx application is running on my PC. So I am the end user with an application that is running, that is Cisco Web System. But I am connected with you through a service provided by the Cisco Web Server. So this server would be somewhere as a content provider network, a data center network, which is given in the PPT on the right extreme. This helps the application from my end to connect to the web service at your end. And on the other end, you are also connected to this data center, making this networking possible. However, it's not as simple as we see here. It would have in between a number of other devices that would help us to connect. For example, from my PC, I am connected to a hub, or let's say a small switch. From that switch, I am connected to a router. That router would connect me to the router of my internet service provider. Let's say in this case, it is BSNL. From that ISP's router, this ISP would be located within the, let's say, Srinagar's BSNL Srinagar network. It would have a connectivity through a WAN to another server which would be located somewhere in Delhi. This would connect to the content provider that is given within the figure. You likewise would have from your end different nodes. For example, if you are having a phone, through your wireless tower, you would be connected through a data service to the internet service provider, let's say Jio. From Jio, you would have connectivity to a BSNL, and then it would have connectivity. What I mean to say here is that in the connection between the end systems or the hosts, there would be a lot of intermediate nodes. We'll call them as intermediate nodes. And what are these intermediate nodes? These can be hubs. These can be switches. These can be routers, right? These can be servers. All these devices are known as intermediate devices, also termed as packet switching devices. This is the second part of it. And the third part of it is, fine, now we have devices. My device as the end device, intermediate devices, and then we have the hosts or the data center network. How do we connect with them? We would require different communication technologies to connect with them. What communication technology I'm talking about? It can be a wired communication link, or it can be a wireless communication link. Wired communication link, I'm talking about the different types of cables. The different types of cables that we come across is UTP, Cat6, and so on. We would see these types of cables, switching devices, and all when we start the OSI layer. That is, we'll start with the basic layer first. That is the physical layer. We would also see that we have a wired or a wireless connection, a satellite connection, how transmission goes, and different terminologies that are related with the transmission, that is the bandwidth, the delay, and so on. So by now, the nuts and bolts view of the computer networks that we come across, you host intermediate devices, the links connecting those, this will overall make a network. And then when we see a bigger picture of it, you have a small network within your home. You call it as home area network. You have a small network within yourself. Let's say you have a mobile phone, you have a smartwatch, you have a pager. There are different devices which are connected with the internet, but they are with you. We call them as a personal area network, that is PAN. Then comes, if it's really close to you, you have BAN, that is body area network. From body area network, then to personal area network. Then we come to LAN, that is local area network. We understand what LAN is basically geographically, which is at a specific place. If you're sitting within the lab, all these computers, 50 computers within your lab are connected to a single switch. This constitutes a LAN, that is the local area network. Then we can move to a different topology in which one router is here. Like I said, BSNL's router is in Srinagar. Another router is in Delhi. They are connected to each other. They form a network topology which we know as WAN, wide area network. I believe when you studied data communication, the last part of it might have touched this PAN, BAN, LAN, WAN, CAN, CR. Ramanand. Ramanand, what was the last thing that you discussed in Datacom? Have you touched these technologies like LAN, WAN, MAN, BAN? Or anybody else? Have you taken those topologies like mesh, bus, and so on? Okay, okay, good. Then most of them say have taken these bus mesh. What we can do is, uh, okay, okay, fine. I get it. All introduction. I would suggest that you go ahead and revise those, but still, in our next class, we can take up and revise these, mesh and so on, mesh network. Okay, I'll move to the slide number 4. In sharing, I don't think it would be, is it visible in sharing? Slide 4? No, if it would have been visible, then I could have simply written on it. It would have been easier for me to mention it. Anyhow, I'll give it a try again. Okay, other than that, you can see your slide, which is showing a number of devices. This is the example that I gave you just now, which says connected devices. We have plenty of connected devices, and even your watch, even your specs are smart nowadays. That's why we see that there is a need of understanding what protocols they use, right? Okay, fine. If it's still not visible there, then let's try to see it. How about now? I have shared once again. CR, anything? Anyhow. Nuts and bolts. Okay, some are Sagar is getting, yes, Sagar is getting that. All right, Naveed also getting that. Fine, fine, fine. All right. So now in this nuts and bolts view, we come to another part. If you see the picture, I'm talking here, for those who cannot see it, I'm talking about slide number 5. In the center of it, it has mentioned local or regional ISP, right? What is ISP? ISP is Internet Service Provider. Internet Service Provider, if you're connected through Geo this time, using your network, your Geo is your Internet Service Provider. I'm connected through BSNL, so BSNL presently would be my local or regional ISP, Internet Service Provider. And what is Internet Service Provider? Basically, it is the agency that gives me connectivity through its links, through its routers to another possible local regional ISPs or national global ISPs. And each ISP would have its own content providers who would provide content to it. The next would be the protocols. The term protocols, I'll come to it, which is in the coming slides, what it means. They help us in connection, in receiving and sending of messages. Like we are streaming a video this time, we would have a protocol of streaming video, whether it's using a Skype, whether it uses TCP, UDP. We'll come to that when we come to the protocols. I move on to the next slide, which says the internet, a service view. Slide is visible. All right. Okay. Now, if I talk about the data network or content provider, you move from the local ISP to the right side in the figure. It shows that if I am streaming a video from a mobile network, whether it's a car which is shown in the mobile network, through the links that has been provided onto a server that is within the data center network, then I from my end using another protocol can access through these mesh of laid down routers, laid down links to the same server. Like you see, Facebook has a live video streaming. How is that made possible? At one end, you would have a device capturing the video. It streams through this mesh to a Facebook server that would be somewhere within the data center of Facebook. And you have been provided a link to that server in which you see this video live. Or in this case, where Cisco would have its own services by which I am streaming this video live, you are connected to the same server where this streaming has been done. How? With the help of all the mesh of network that you see under the red line. Okay. So we just now mentioned that whether it's HTTP, whether it's UDP, TCP, what are we talking about? We are talking about a terminology that we say protocol. That is basically our main thing that we would be trying to understand what a protocol is. Now, as an example, I have CR on the other end. CR, unmute your microphone. Okay. CR, I'll ask you a question here to reply back to me. What is the time? Okay. So what I did is I asked a question, and as a human being, as a human behavior, he replied back to my question saying what the time was. It can be some other way as well. I asked CR, what is the time? He says, sir, I'm having my breakfast. Please don't disturb me. It can be, I can ask him, what is the time? He says, sorry, I'm busy at this time. It can be, what's the time? He says, sorry, I don't have a watch. So the way I ask a question and he replies back to me constitutes what we know as a human protocol. Exactly in a similar fashion, over the internet, what do we have? We request something and we are served back with the message. Now, at times when you go to google.com, you get a page back which says, this is the Google page that you were looking for. At times you request a Google page, it says page not found, error 404, and so on. This error 404 is similar to what CR just now would have said, that sorry, I'm busy. Or I say, CR, can I have the attendance, please? He says, sorry, I don't have it. So error, page not found. I asked him, what is the time? He said, I'm busy. So I asked google.com to show me the link. He says, it took time. You see that streaming, downloading or stuff. And at one point of time, you get a reply that server busy or host busy, could not connect. So what basically this is the similar human protocol that we use, but This is the protocols that our computer network uses. We define by the term protocol as rules. And what protocols do we use in computer networks is rules for communication. I need a file, I'd request for a file. For example, I need to download a file. I would have to have a specific message for downloading a file, like FTP. That's file transfer protocol. Or I would need a specific Google page. I would use a different protocol, which is, let's say, HTTP, which would be to download a hypertext content, a page, an HTML page, or so on. So we can have specific messages sent, and we would have a specific action taken when this message has been received. It can be that Ramanand here may not be listening to it, may be busy doing something else, and I asked him, what is the time? I do not get any reply back from Ramanand. Okay, I try again, what is the time? I do not get any reply back again. So likewise, sometimes servers are busy. You send a request was not heard by the server. It has services which are supposed to hear it. Go back to operating system, RPCs, IPCs, where we discussed that there would be a daemon who would be listening to requests. Yeah, that reminds me, operating system papers are under process. I'm still checking, but let's see. Anyhow, so once I requested something, but it could not receive, the daemon there could not receive the request from my side, we say again an error. You would need to resend it once more. You ask it again and again, like I asked Ramanand. So in short, I would have a specific message sent and a specific action would be done when the message is received, or any other event would take place in that case. This is what a network protocol basically is. And all communication, all activities in the internet are governed by these internet protocols. By definition, you would see in your book, what is a protocol? Protocol is a rule. Or protocols define the format, order of message sent and received among network entities, and the action taken on message or transmission or receipt of that. It can so be that message is not received. In case the message has not been received, then also your protocol has to say what next, resend, and so on. This is the slide, what's a protocol, a human protocol comparing with a network protocol. Ramanand, is it visible? Okay, seems that it's working fine. And for others, I am this time on slide number 8. Those who cannot see the shared screen. Now in this case, see, what are the end systems here? You and me and Ramanand. I said hi to Ramanand. He said, hi, good morning, sir. I said, what is the time? And he replied back with the time. If we compare this with the protocols that we are going to study in this course, my laptop connects to the Cisco WebEx meeting. How? I send a request to it. How? A TCP request, let's say. What is TCP? We are coming to that in future classes. And what is the response that I get from the server? I get a TCP response, means the hi or good morning to Ramanand was replied by good morning from Ramanand. And my TCP from the laptop was replied by the TCP response from the server. Then once I ensured that the other party is there, Ramanand was there, then only I would have like, okay, Ramanand, what is the time? Then he replied back, sir, the time is 11:40. And likewise, once I got a connection from TCP with the response, then I asked the Cisco create a meeting using this detail that I have given. Then I got reply back that yes, the room has been created. You can share the link and so on. So with reference to time, you can see how the connection has been set up. I'll move on to the next slide. Okay, I'm on the slide number 13, which says access networks and physical media. It says how to end systems to edge routers. We can have a wired or a wireless connection. If you're using this application of Cisco WebEx over the mobile phone, then expect this access network to be a Wi-Fi, a 4G, 3G, 2G network. If you're accessing this through a wired connection, for example, you're sitting in the computer lab of a department, the computer is connected through a Cat6 cable, then to the router and so on. We would be connecting basically to a router, which is known as an edge router. In both the cases, whether it's wired or wireless. And if it's cable-based access, if it's wired access, we will study in our the basic the first layer protocols in which we'll come across FDM, TDM, which partly you might have taken in data communication as well, the access methods within those networks. We will also discuss about how these cables are used, what type of cables are used. In the meantime, we would have to have our labs as well. In the lab, we had previously taken labs, firstly, to make these access methods using wires. We did crimping of Cat6 cable, which as of now may not be possible, so we'll delay that. We'll start with our, lab one, which would be basic, basic terminologies that we would come across in the networking. Like most of you might have used ping as a tool to see whether you are connected to another device or not. You might have used a command like traceroute to see whether you are connected across or how many intermediate devices come across between you and me. Like we saw just now, between you as an end device and the Cisco WebEx server, there would be a lot of routers in between, lot of switches in between. There are different methods by which we could see how many devices come in between these, how many hops are there. So this all we would learn from our lab number 2, for which I would share the slide. I would share it. I don't think this sharing is fine here. So what I would do is I would share this to CR, and Ramanand would pass that slide to you. Then we'll discuss in our classes, let's say next class, if you had any issues with it. Or we can parallelly, if that would be possible, you can also, I would use those commands. You can also try those commands and see whether these are working. But then we would require some softwares to be downloaded. So I would suggest I would send the PPT Again, I'll check whether it's available with me, but I would have that because I would have previously sent emails to the previous groups. Um, Also, I believe we might need like Google Classroom, like Google Board, where we can share these slides and we can connect. Also, maybe give you an assignment as well. Well, yes, by assignment, I would get to know at least you are on track. Okay, so that would be the lab part that would be taken care. All right, any questions till now? No? If you have any questions that if you are not able to ask, you can type in the question here as well. Another thing is if I'm not clear, your internet speed is not good, we would be recording this lecture and we would put this on our website as well. You can download it from there. All right, are we clear? Yes, I couldn't get it. Okay, fine. Now I'll move on to, since we are taking the history of it, let us see the basic from where it's all started. I believe this history is towards the end of the slide. Move to slide number 70. How this, internet came up. I'll go to a different source here, which mentions the history, how internet actually has started. Whether this is truth or whether it is not, that's a different question. But this is, I mean, what I have read about the history of internet. They say that uh, when the Russia and America all were looking for a technological edge after the Cold War, each one of these countries wanted to show that they are, superior technologically over the other country. One of the countries launched Sputnik. They sent the first man into the space, and the other country, United States, that time somehow would want that to know we are technologically better than Russia in those terms. So what they did is they had a project in which they decided that we will connect the radars that we have across the United States. A project known as SAGE, Semi Automatic Ground Environment, was taken up under DARPA. DARPA is still one of the best known research organization of United States. This was the Department of Defense project. Those are the ones who started with ARPANET, DARPANET, and so on. The basic networks that we see today, or the mother of all networks that we have. So when these radars were connected, what the purpose was that some information from one radar connected to, or should be able to be sent to another radar. And this is what led to the early packet switching. Then we come to the 60s, wherein packet switching networks came into existence. We saw ARPANET coming being. ARPANET is basically Advanced Research Project Agency. Their network, ARPANET, which is basically, I mean, many books would say the first known networks that we see. It was mostly that time research oriented. Then came the network in which they send the data from one university to another university. the several universities within the United States were connected to each other. In 70s, the ARPANET moved from the uh, you know uh, research domain to public domain. Certain protocols came into existence. Earlier known protocols is NCP, which is the Network Control Protocol, also known as the first host-to-host protocol. In 70s, there was the first email program that was written. And you have to understand that one of the basic ARPANET that was made had just 15 nodes. And this time we are talking about billions of nodes. Move to slide number 71. It has some internet history written there. From 70, from slide number 70 would have the 60s. Slide number 71 would have the 70s history. Then we saw in 1970s Aloha Net, which was basically a satellite network in Hawaii. Winton Cerf and Robert Kahan, they gave the basis of the architecture of interconnecting networks that time. The term internet was not given at that time. This was in 1974. Then came the Ethernet. We'll see what is Ethernet when we come across the OSI layers. We'll come to the layer 2 where we'll discuss the Ethernet in detail. In 76, it was given at Xerox. Late 70s saw different architectures of basic networking. One of them was DECnet. What was the difference between like the previous decade and the next decade was the number of nodes increased. We saw in 60s, I said 15 nodes. ARPANET in 1979 saw 200 nodes. A big contribution from Winton Cerf and Robert Kahn is the architecture or the basis that they gave. They mentioned certain terminology which are still defined in present day internet, like a best effort service model. What is a best effort service model? We say, you might have heard that internet best effort service model. The best effort service model says that I would try to deliver the packet in the best available time at best available speed, but I do not promise it. Likewise, other terminologies like routing, decentralized control, were taken there. From 70s, we moved on to 80s. 80s had a major term which we call as TCP IP. In our probably next class, we'll see on one side we have OSI layer, on other side we have TCP IP. That is the different layered architecture. Based on transmission protocol, internet protocol, this is the present internet that we see, which was given in 80s, the transmission control protocol and internet. Also, the protocols related to email came into existence in 80s, which we presently know as SMTP, Simple Mail Transmission Protocol. DNS, FTP, TCP, all are from 80s. And the difference between the previous decade and the next decade was that from 200 nodes, we had around 100,000. That would be 1 lakh or more hosts that were connected across United States. New terminologies like NSFNet came into existence, BitNet, CSNet, and so on. Then we move on to the 90s and the 2000s. The main term that we come across from 90s was web or www. Main contribution given by the Tim Berners and Lee. They gave the term as www, or what we come across today also as HTML, HTTP. They mentioned that we would need a software that would help us in easily communicating data across. And the software was an application program that we presently know as a web browser. We understand that. Okay. You can ask question here as well, on the chat on site. Since it's an introduction, so yeah, there might not be that many questions as of now. Mosaic was the earlier known the web browser. Web browser. I'm talking about Chrome, Internet Explorer, Edge, Firefox that we presently know. Earlier one was Mosaic. Then came Netscape. And 90s also saw commercialization of the web. Means that industries and all took up this web, and then we saw e-commerce and so on coming. Also, when we come across from 60s to 70s to 80s, we see different, generations as such, 1G, 2G, 3G. In terms of what? In terms of the network speeds. I don't mean the present 3G, 4G. We move on from simple, BPS, that's bits per second, from 60s to 2000s, wherein we see backbone links which have speed of gbps, gigabits. What are backbone links? Backbone links are those links which would connect one ISP with another ISP. Let's say we have BSNL network at Srinagar. It connects through a number of fibers to the router which is in Delhi. Let's say both are of BSNL. But the connection between this router and this router using a fiber can take many, 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 hundreds of Gbps of load. Why? Because it is taking a load of a whole bunch of people. It's taking a lot of load in the sense that it would have to carry several terabytes of data within a specific time. That's why we would need the basic or the core networks to be very strong, or backbone network. Another thing that we see while moving towards 2090s is the number of hosts cross more than 100 million. We had applications wherein instant messaging started. Probably you might not have heard of those type of instant messaging at those times. There came P2P file sharing. Uh, Earlier, the ones which you might have seen, the earliest one, instant messaging, was for you, probably Yahoo Messenger. There used to be IRC, Internet Relay Chat, which was I believe, earlier one chat application that I have come across, IRC. Okay. Now, presently, if we see where internet has reached, we see billions of devices. Just see, and as an example, most of you would have a Facebook page. Facebook has approximately 2.5 billion users. They have their own networks: Google, Facebook, Microsoft, Cisco. They have their own networks created. They have, what I mean by networks created, they would have their own cloud service, Amazon Web Service, Microsoft Azure, all are these cloud-based services. They have their own storage area networks, and they are really huge networks. The connectivity presently that we see is internet is everywhere, whether it's through Wi-Fi, 2G, 3G, whether it's wired, wireless, you would have a broadband access, or these type of accesses to everybody. This rose again with the help of smartphones. The iPhones that we saw around 2007. Yeah, 2007, the iPhone came with this concept of smartphones. And like I said, by 2020, it's believed that 33 billion devices would be connected to the internet. This was the brief history of internet. Okay, is that fine? Okay, Ramanand. Okay, should we continue or we stop our first class today? Okay. Can you tell me how much is the expected size of the video that you recorded? Oh, okay, all right. So I will end our first lecture today. This was basically introduction to computer networks. The In our next lecture we'll pick up the delays. We'll see what type of delays we come across. Okay, regarding the book, this slide is from Kuros. Okay, I would suggest that Tenenbaum and Kuros are two good books. You can refer to them. If you go to the first slide, it mentions on the right side the book, Computer Networking, a Top-Down Approach, 8th edition. The only difference is that I won't take top-down approach, I will take bottom-up approach. I would start from layer 1 and go up to layer 7. This book would start from layer 7 and go to the basic layers. But this is a good book. You can have this one. You can use Tannenbaum, or if you have any other book, it should be fine as long as you understand what we are discussing. Regarding our lab, I would share the lab number 2, since lab first one, you would have to physically do that using crimping and all other tools that are available within our lab. We'll delay the lab number 1. I'll give you around a week's time to try lab number 2. If possible, if we can do lab also using Cisco WebEx meetings, this should be fine as well, right? We'll try to have, you know, sharing through other means. Raman, what have you used for other courses? Okay, fine. Then we will share using Google Classrooms as well. You'll have updates there as well. You have any questions? You can also email to me. I'll just share my email, but preferably Google Classroom should be okay for that as well. All right. I think I'll stop here now. I'll see you in the next class. If you have any issues with the timing, please discuss with Ramanand, and we can have time, we can discuss as per your timing. Stay home, stay safe, take care. Bye-bye.